Welcome back to Dissect the Question. A 26-year-old male athlete is awakened from sleep at night because of painful muscle spasms in both legs following a 3-hour workout at the gym. Which of the following physiological mechanisms is likely to decrease this man's nighttime muscle spasms? So the first step is to just ask, what's a muscle spasm? A muscle spasm is a high excitability state, isn't it? Increased excitability. When we have a spasm, it can be very painful because the muscle contracts and doesn't relax. That's what a spasm is. So we're having high excitability. So we want something that's going to decrease the excitability of the neuromuscular junction, either the nerve, the motor neuron, or the muscle, or both. So let's see our choices. Decreasing plasma calcium. So let's see what happens when we decrease plasma calcium. Here's our motor neuron. Here's our motor neuron's terminal with vesicles containing acetylcholine that are released onto the skeletal muscle with its acetylcholine receptors. And part of the acetylcholine receptor is the acetylcholinesterase that breaks down acetylcholine. So when acetylcholine attaches to the acetylcholine receptor, it opens a channel for sodium to enter. Sodium. And it's a non-selective channel for sodium and potassium. So sodium comes in and potassium goes out. More sodium comes in than potassium goes out, and therefore the net effect is a depolarization. That's the high excitability state. That's the action of acetylcholine. Now, if we decrease the plasma calcium level, we know that plasma calcium has an effect on sodium channels, but not these ligand-gated sodium channels. So the sodium channels or sodium-potassium channels at the motor end plate are ligand-gated. What calcium does in the plasma, it blocks a little bit the voltage-gated, VG, voltage-gated sodium channel. The voltage-gated sodium channel is responsible for generating the action potential that's going to release the acetylcholine. There's also a voltage-gated calcium channel that's going to help in exocytosis of acetylcholine. So if we decrease the plasma calcium level, we produce a condition known as hypocalcemia. Hypocalcemia produces a condition known as tetany, which is a state of increased excitability. Why? Because the calcium at the voltage-gated sodium channel is blocking or keeping the sodium from coming in too quickly. If we remove the calcium, bye-bye calcium, then sodium comes in faster, and we have a hyperexcitability state that's going to make the spasms worse. So we're going to eliminate A. Let's eliminate A based on what we just said. If we decrease plasma magnesium, it turns out magnesium and sodium, magnesium and calcium have a similar effect at blocking the sodium channels. And therefore, we're going to get an increased excitability state. So hypocalcemia and hypomagnesemia can have the same effect of increased excitability. Now, what about increasing the plasma calcium? Well, then instead of producing hypocalcemia, that will produce hypercalcemia. We'll block those sodium channels. We'll have less ability to produce action potentials in the motor neuron, and less release of acetylcholine. So that's certainly a possibility. And that looks like a good answer. On the other hand, there may be two good answers, and we have to pick the best one. You know, when you do multiple choice questions, you always have to pick the best answer when there's two. But we haven't looked at D&E, so we don't know if there are two possible answers. We've already eliminated A and B. Can we eliminate D&E? Increasing plasma potassium produces a condition known as hyperkalemia that causes potassium to accumulate inside the motor neuron and inside the muscle too. If potassium, being a cation, a plus charge, accumulates inside, then we're going to have more action potentials, and it's going to make the muscle spasms worse. What about increasing the plasma sodium? Well, that produces a condition known as hypernatremia. If we increase the plasma sodium and produce hypernatremia, when those sodium channels open up in the motor neuron, excess sodium is going to come in. And again, we're going to get more action potentials, more release of acetylcholine, and a hyperexcitability state that's going to make the muscle spasms worse. So we can then eliminate D and E. And C is clearly the only appropriate and best answer. The take home here is that we can administer calcium intravenously, increase it in the plasma. We can also give magnesium as drugs to decrease excitability when a person's having a muscle spasm.